Hello there, my mate Vince here, and in this video today we're going to try to fix up this smart socket here. So this is a UK power outlet. Yeah, it's smart, so you're supposed to be able to control your appliance that you plug into it via, for example, your mobile or your voice via Alexa. Or it says touch as well, so old-fashioned way, just on and off. It says, "Dear Vince, please find and close my smart socket. It recently suddenly stopped working. Luckily, I was sent a replacement under warranty, so it can't be that old. So you can do what you want with it. I hope you're able to repair it, as I trust it will make for an interesting video. I've only been a fan of your channel for just over a year, but I've already watched most of your videos, including the Rolls-Royce series, which I enjoyed very much. That series is now finished. This was sent in probably about a year ago. I'm very impressed with your knowledge, skill and determination. Keep up the good work, Simon." So massive thank you, Simon, for sending this in. I am not going to connect it up to mains just yet. Let's take it apart and see if we can find out what. Maybe we can follow some traces or something. We might see a burnt component. Is it going to be a is it just going to be a smart thing that's not working on it, or is it going to be some physical thing, like, you know, maybe the switch or whatever's not clicking in? So we should have, that looks a little bit burnt there, does it not? That plastic looks a little bit melted just there, but mind you, that one does there as well. It might be dirt. So on a UK plug, this is an old one here without the insulation, so you can't use these anymore. But can you see the earth pin's a little bit longer than the live and the neutral? And the idea is the earth pin hits this bit first and then it opens up the shutters. Can you see there? So if kids are playing nearby, young kids, they can't shove anything into here. They would have to shove it into here first and then get something else to shove into there. So it's a nice, simple safety design. First things first, I'm going to take this apart. So I'm going to hope that, well, actually, no. First things first, let's see if we have continuity between the earth and here. Yes. Now I wonder, are we going to have continuity through here? I suppose we're not going to, are we? Because that's the whole point. It's not going to be allowing the path through. So let's take it apart. To test it working, I could just put it on a plug top anyway. You know, I can just get a bit of flex with that one. BG stands for British General. Hold on now, they're riveted here. Yeah, I'm gonna have to break the rivets. So they're not actually repairable. So it's just going to be a case of finding out what went wrong with it. But that's not. I'm not going to be able to. I'm not going to be able to rivet that back on again afterwards. I wonder, is there a way I can crush it, which would then allow me to maybe lift it off the thing? So that's what I do. I crush it with pliers, and bit by bit I kind of crush the inside of the rivet to allow it to pop out. I should, in theory, be able to put it back through and then stretch out the bit that I crushed to kind of make it into a rivet again. The reason you need to have this intact is because, you see, you're screwing a metal screw into this. Now imagine if that metal screw was to then go through and hit the live wire. Then what would happen is, because it's all intact, the live would be contacted with earth and then your breaker would trip on the main fuse board. But if this was insulated, so let's say now if that rivet wasn't making a contact, or if you got rid of the rivet completely, then that screw could in theory be live, and somebody could come along, touch the screw and their radiator, which is probably going to be earthed, and then you see they're going to get a nice little, well, not a nice, a very horrible shock. There we go. That's going to pop out. Result. Well, look at that. Now, I wonder, can I leave that side in? Will there be enough room to take it out? Maybe. Do you know what? I'm going to bend it. There. Wow. We've had an explosion. We have had an explosion. Okay, I'm going to have to worry about all them after. Looks like we're missing a screw. Oh, mind you, we only need 3. That must be for something else. Right, what is going on? What's blown up? Something's blown up. What has blown up? What are these? They relays? Definitely been a bit of a fire in here. Just going to take a picture so I know how to put it back together. Right, so that side actually looks okay. It's something on this side. It looks to be kind of down in this area here. There's a lot of burning going on around here, but these might be okay. I think it's something deep in here which is gone. Now, are these going to come out? This is useful. Excellent. Oh, hold on. Is that on fire there as well, or is that just charred? That must be some kind of like Wi-Fi board. I think that's okay. It looks to be down here. These, I presume they're going to be some sort of diodes. I think now that we know where the epicenter of burning is, because can you see it looks like it's all shiny from here, like here. I would say it's going to be that one there. I don't actually know. Oh, hold on. Should there be something here? What's this? Is there something here? What is? I can't even really see what's going on. Could it be these transistor things? Right, I'm going to get the IPA on it, give everything a clean, and then the burnt component might rear its ugly head. Just clean it with some isopropyl alcohol. So I presume these must be relays, and then we must be having some sort of switch mode power supply in a way to reduce the voltage down for the Wi-Fi socket, the Wi-Fi chip, and then it must do a low voltage signal to the relays, like for example 30 volts DC, to then allow it to turn on and then allow the power to go through. You know what I mean? From to allow the power then to actually travel through it, the mains to travel through it. I'm thinking. I don't know though. I'll have to have a close look at the socket and see if I can work out what's happening. So maybe this is like a relay for the live and a relay for the neutral. In fact, I think I'm going to take these relays out, and that will give me a lot more room, because I still can't really see down in here properly what's going on. And then I might be able to trace it more, what's happening. I might even be able to check these with my bench power supply, because I think that goes up to 30 volts. We might hear it switching. Okay, I'm going to take out these big relays here, purely because they're taking up most of the board. Also, it looks like some of the tracks underneath might be now copper, so I just want to see maybe the burning's coming from under here. Looking at the diodes now that they've been cleaned up, they don't look too bad, but the transistors above them look very bad. Like there's legs missing and stuff off both transistors. Wow. Okay, so I presume these little ones are the low voltage and the big ones are for the mains voltage. So when power is applied here, these will join together. Now what's happening here? Let's clean it up and hopefully it might make more sense. So these are connected out to the actual plug. Yep. So when power is applied between here and here, then this one here is going to join to here and put, for example, the neutral through. And on this side, this will put through where when this one is joined to here, it will put power through from here to here. Wow, it's actually burnt into the circuit board itself. Yeah, that's completely burnt away there, look. Okay. There we go, so that's why it's not, that's why it eventually failed, is because it can't get the low voltage signal because this isn't connected to the relay here. Yeah. But if you have a look here, can you see that this is all burnt now? There's no leg here, no leg there. And I don't know what's happening with that top bit there. I don't even know where it was soldered, it's all bent to the side. It's very odd. I'm wondering, do I take it any further? We know what the problem is now. But I wonder what failed to make this happen. So what's driving? So this is being driven from here. Where does this one? Let me find out where this one goes. Does it go to there? Yeah, it goes to there. And then this one here is fed from here. So that is still actually intact even though it looks a mess. And where does that go to? It goes along to, is it this side of the diode? Yeah, so this goes to here, this goes to here. So if this goes to here, then this I would have thought, why is that short into there? Is that normal? Hold on. That's not normal. So did this diode fail? So that's short. And that's not. Right, let's zoom out to get the meter on here. I'm just going to give it a one more clean up. I think the diode failed. But I wonder what caused the actual fire. By shorting these two, would that then that wouldn't live, hold on, shorting these, so you put power into these two, you energize it. You're energizing a coil, yeah? But if that goes short, what happens to that coil? Not too sure. Or do you reckon some water or something got in it and it tracked from here to here? It looks like, you know, it looks like the burn went from here to here and this has been blown and this has also been blown. Do you reckon this was component failure, or do you think it was user failure where maybe water accidentally got into the socket and then tracked between here and here, and then you're putting the high voltage down into the low voltage side? That probably would have this effect. Not sure. So if we go to the diode on the right hand side, I just want to see if they're both the same. T42027, T42027. Well, the markings are nice and clear on there. So if we go, remember this is in circuit, but if we go here, nothing. Swap the leads. We have a reading. And are they the same way round? No, opposite way round. So now if we have a reading this way, we should have a reading this way on this one. But the readings are dead short. And then if I swap now, it should be open. So either the diode's failed or something on the board. So let's pop that one out. I'm just going to take a picture so I know again which way they should go back on. I'm just going to take this out of circuit just to make sure that the board's okay underneath, in case it's a board that's short and not the actual diode. Right, we'll just go to continuity. Yeah, there you go, the board itself is okay. Yeah, well if you have a look here, short, short. So that diode has gone, so I need to find out what that diode is. Let's have a quick look here to see if we can work out what's happening. So, where does this go? This goes to this part of the transistor, and to be fair, it's still getting there. How about this one? Oh, it's the other way around, so it'll be here. That's still getting there. And then that side goes to the hole, and then this side... No, hold on, I'm getting confused now. I think these two are actually on the same. Yeah, they are. So basically, they would have gone up this trace here onto this one here, and you can see the via's completely gone. And so this one goes off to a via. So where does this go to? And we might, in fact, it goes off to two vias. Here and here. What's on the opposite side there? That's not helpful. So it is a multi-layer board. So it means it's travelling down the middle of the board somewhere. Ground? Oh, it's a ground. Ah. So it looks like that's going to be ground as well. So that's going to the via. So the via is still intact. Okay. Now, where does this side go? Up to that resistor. And up to that resistor. So what do we need to get this working? We've got a we need a new transistor, because this one's blown, unless there was a way that I could somehow... Let's unsolder it. Let's see if there's any little bit of leg remaining on the bottom. And that, believe it or not, is actually still intact to there. And we need a diode, and we need to renew this here. Let's turn our attention, before we worry about that, onto the relays, see if we can get the relays working. Because maybe they're gone as well. This can't be put back into service. It's just, it'd be nice to have it working for the end of the video. Right, I'm going to see if I can get a pin out for this. Well, mind you, it's a coil. That's right, isn't it? So it shouldn't matter which way the... I'm not going to blow anything by putting in the voltage wrong. So I'm presuming it's going to be 30 volts to switch it, because it says 30 volts there. So I can get my bench power supply. And I'm not going to do 30, but let me start with 15 volts and see if that's enough to make any noise. Actually, let's be sensible, just in case, because I haven't looked up the spec sheet. Let's just go to 5 volts, and let's see if that makes any noise on them. So 4.8 volts, I just want to see if it does any clicking. Listen. There we go. I'll tell you what, let's go to 3.3 volts then. Maybe that 30 volts is just what it can take, but maybe it operates on 3.3. Listen. So I think the relays are okay. So we shouldn't have continuity between here and here. No, and no. But when we apply voltage, we should. So let's put this one here. Need more hands. Right, now listen. There you go. Okay, that relay is working. Let's do the same with this one. That relay's working as well. So relays are good. So I think if we got a new diode and a transistor, I think we might be able to get this working again. So let me see what the diode is. T4 2027. Right, it is a 40 volt, 5 amp Schottky diode, and it's for quick switching purposes. There's a switching diode. I don't think I'm going to have any of them. Right, I've been having a look at the parts that I've already got. Now, these are easy to buy. The L6 transistor, you can buy like 10 or 20 of them from eBay for a couple of pounds. Also the diodes, T4, also known as a 1N4148W, again on eBay. You can get them for dirt cheap. They're not a lot of money. Problem is, I haven't got them. I went all through my little transistor kit here, and I thought I had a diode kit. I've got the through-hole diodes, but I thought I also had an SMD diode kit. But no, I haven't. So that's one thing I do need to buy. But what I have got is, I got these. I can't remember what they were for, but I have got these diodes here. So I am going to use, obviously, don't copy what you see in my videos. This isn't going back into service. I'm not going to put that back into service. You can see it's all burnt and charred everywhere. I just want to get it working, just to. Just for the end of the video, I think it'd be nice to see it work. And I think what's happened here is the diode's gone short and it's just caused complete and utter mayhem. So this is what I'm going to do is I'm going to put in two of these diodes. I'm going to take out both the diodes in here. Well, one's already out. I'm going to take out the other one as well, because if I have a complete mismatch, it might be all over the place. While if I put two in the same, at least the neutral and the live might be doing the same thing. I mean, some people are probably shaking their head now thinking, what on earth are you doing? But it's only just to get to the end of the video, just to see if we can make a light up or a hairdryer come on with my mobile phone, or maybe using Alexa or something like that. So I am going to, I'm looking at these now, they're complete different size difference, aren't they? Should I put a mismatch in? I'm not sure. I was going to say I'm going to change both of them over so the live and neutrals at least will be working at the same sort of time. I'm not too sure. I'll have to see if I can fit them both in or not, because this is a lot bigger. So basically the T4 diode that's already in there, that blue, is 100 volt, 150 milliamp, and it's a fast switching diode. This one here is an SP280. It's an 80 volt, 2 amp, so a bit less on the voltage, but can handle a lot more amps, hence the reason it's so big. They're both Schottky diodes, so they're both fast switching. Whether this one is as fast switching as this, I do not know. Clearly, you should be just putting in what you're taking out, but again, I'm not putting this back into service. I'm not going to keep saying that. You know what I mean. So please don't say what you've done is highly dangerous and I've shown people how to do the wrong thing. I don't know how much more clearer I can make it. This is only for the video. Now, when it comes to the transistors, it's NPN, 50 volt, 100 milliamp, collector base emitter. That's the L6 one that's in there. I'm going to put in a J6 one because I haven't got an L6. S9014. It's an NPN transistor. It is a 45 volts, so a little bit less on the voltage, 0.1 amps, which is 100 milliamps, and base emitter collector. So I think they're going to be very similar. So bear with me. I'm going to put in two new transistors, two diodes if I can fit them in. I'm going to solder these back in, and I need to redo that trace there, and then we'll see. And I also need to put nail varnish on. There's quite a bit of work to do actually, but let's get started. It's going to take me a while. Yep, it certainly does take a while because it's not just the components, it's all the rebuilding of the traces as well. I'm just using little bits of wire for that. They look massive on the screen, but they are tiny, tiny bits of wire. They're not tiny, but they're just kind of little speaker wire that I'm using for this. I just used something that I had to hand. You might wonder in a little bit why I take off the capacitor. Is because one of the broken traces, the burnt out traces, goes slightly under the capacitor and I need to lift it off to actually get a good purchase on the trace. While I'm doing all that, I'll shout out them, My Mate Vince Massive. They're the top level Patreons, and the members this month are kipdigital.com, Kip Hakes, Max Rokotansky, Chris Seal, Felipe at MrKeeps.com, DJ VG, Pixie, Anthony Dean, Bazza2, Russ Melanson, Gaspar Heller, Ricard Berglund, Soul Reaver 555, Shamsa Al Sawadi, Stuart Park and Stephen from the Broken Past over on YouTube. A massive thanks to each and every one of you. Some of the people on here have been on there for feels like an absolute eternity, which is of course extremely generous of you, because it means that videos that may not do so well with the YouTube algorithm is still worthwhile doing. when you put in a little bit of sponsorship and a bit of Patreon, some people use a bit of merch and stuff, it all adds up, and it means it's still possible to be able to make a living, even though you might make videos which don't really get huge traction with the wider audience. Now, sit back, relax, listen to a nice bit of music, and watch me solder all these things back into place.
Bubblegum fights on the third floor. Comedy specials at 8. Fishing rod in a quiet field. And what I caught wouldn't be big enough for you and I and say I did great. And all of these moments, they add up to something that feels so big. And all that I'm left with's a dry throat. I lose my head when you call me up and ask if I'm doing okay. Was it easier when I was younger? Did the ones I love seem rosier? Or was it all the trick you played on me? Nowadays we're all so spread out, a time zone for each of our hearts. When tragedy strikes, will we mend up, come together to say our goodbyes, or will we stay apart and leave it all unsaid? Was it easier when we were younger? Did the ones we love, they seem rosier? Or was it all the trick we played on each other?
Right, okay, well, it looks a little better than it did earlier. Obviously the wrong components have been used, but it'd be interesting to see what's going to happen. Now, just in case it all goes bang, so these are going to be the outputs here, these must be the inputs. I just want to make sure that there's no short going into it. That's going to do my fuse board straight away. No, there's not. So this is the neutral here, and this is the live. So I might be okay. Let's just go onto that little bridge rectifier. So what does this one go up to here, I wonder? Yes, and does the live go to this one? I wonder where the live goes across to. It goes up to here. It goes up to this little link, does it? Live to the link. Oh, there's a hidden fuse as well. There's a fuse in here which is also gone. Oh, that's irritating. Right, okay, I thought it was just a link wire, but it's not, it's a fuse. The fuse is gone. Right, let's unsolder that. Maybe there's more stuff gone. Maybe the bridge rectifier and everything's blown. I suppose in hindsight I should have checked that before really doing any work on it. Because I might have just wasted my time. Right, let's see what this fuse is. I wouldn't even know, unless it's marked up, I wouldn't know what to replace it with. I mean, it's a 32 amp socket, isn't it? But what would the fuse need to be? I have to see what those colour codes mean. Is there anything written on the board? No, it just says F1. Before I go any further, let's see if the bridge rectifier looks okay. Going to diode test. Something. No, that's a short. That's a short. Yeah, we have a short. Oh no, Vince, you idiot. I've spent so much time on this. And I wonder, is it the bridge rectifier that's gone? Or is it something else? We've got a short, so it's going to have to be... It can't be anything else because we're shorting from AC to DC. So the bridge rectifier is also gone. 10U10. I see a diode in here as well. Let's just see if this diode's blown. See, the chip and everything could be gone. Strange reading. We're getting reading both ways, but it is in circuit. Yeah, it's not a direct short anyway. Ah, IPA gone. Of course. Let's pop the bridge rectifier out. Bit dodgy heating up so close to the caps. Right, I'm just going to test that out of circuit. Yeah, there's a short between the AC and the DC. Yeah, okay. So if I put it to continuity, there shouldn't be continuity here. I'll wait until my hot air station cools down. There you go. See, there's a short there between that side. So this is the AC coming in, and this is the DC going out. So we've got a short between the negative and either live or neutral of the AC. In fact, I know what it will be because I can go on here. The neutral. So there's a short between the neutral and the negative. Right, let me see now if I have tiny little bridge rectifiers, and also let me see if I can work out what this fuse is. Right, okay, I've just worked something out. So basically, clearly there's 2 plug sockets, isn't there? So I was getting confused earlier. So look, basically the neutral comes in straight from the house wiring. Yeah, we'll forget about earth a minute. The neutral comes in straight from the house wiring, and basically this relay is for this live, this relay is for this live on this socket. They're 2 separate sockets. So I was thinking, how on earth do I know what to put in here? Because it's a 32 amp socket. I'm not going to, how big would that fuse be? But it's not doing that, is it? Because look, this is the live from the house wiring, this is the neutral. So no matter what, the neutral from the house wiring is always going through to whatever you have plugged in. Look at the live here. The live goes down to here, and then the low voltage side of the circuit is going to switch it. Yeah, then it becomes live. Yeah, so do you see it's switching from here to here and here to here when the relay's being livened up. So when this relay gets livened up, it switches here. When this relay gets livened up, it switches here. So really, it's probably going to be like 1 amp is probably ample. So yes, we have got high voltage here, but that's because it just needs to step it down. Obviously, there's already high voltage here anyway. You're not going to have a separate power supply, a separate adapter to plug into your socket to make it low voltage. There's already 240 volts here, but this circuit's going to be running on next to nothing. So even if I had maybe like half an amp fuse, it'd probably be fine. So just purely again for testing, I'm just going to see what I've got. If I've got like a 1 amp fuse, I'll stick a 1 amp fuse in. I don't have anything that looked like this though. I'll probably get away with just putting in a resistor and it would probably work. But I'm just going to see what fuses I've got. Also, I have to see what small tiny bridge rectifiers I've got. Anyway, from what I can work out, it's 4.7 ohms. But how that relates to actual amps, I don't know. I haven't done the sums. Okay, this is going to be miraculous if anything, if I get anything out of this. But basically, I've got a fuse which is going to be far too big. This one is 2.5 amps and is rated probably far too highly. And I've got a little bridge rectifier here, which is B10S. It's 1000 volts, 0.8 amps. The bridge rectifier that is faulty is 1000 volts at 1 amp. So again, kind of similar. So I'm going to try, if possible, to get these in. And I mean, the package size is all completely different. So I'm just going to do this bit off camera because I'm going to have to get my head in to try to make this as safe as I possibly can. And yeah, then hopefully, I'm not sure if that bridge rectifier would have taken something else out. Was it the bridge rectifier that went faulty that then blew something? Or, you know, blew the diode and stuff and caused the fire? Or did the fire happen here? I think the diode went faulty, and then probably as things started to surge, that's probably when the bridge rectifier went, which then took out the fuse. That's what I'm thinking, but I have no idea. Okay, I've managed to get them in. The fuse went in super easy. I know obviously it's the wrong rating, but it was actually, it fitted nice in there. There you go. And what I had to do here is I had to bend the legs straight down, so they're not like sitting on the flats of their legs, they're on the points of their legs. But it looks like I've managed to just about, yeah, it's soldered. So I think we can put it back together and we'll see what it does. I don't want to power it like it is now in case things start exploding. But for all I know, remember it was shorted from here to here. Maybe it could have gone further, but maybe not. It might be okay. So I have to try to get this back together. I'm not going to bother cleaning this because it's not going back into service, so there's no point in having it all neat. Right, I think we are ready to wire it up. Amazingly, I kind of managed to bend the brass back round again, so it is actually in place. Okay, I am going to get some flex and a plug socket, and then we're going to see if it's going to explode. I've got a feeling it will probably explode and also take out my electrics as well. Annoyingly, I can't find my flex cable. I had a drum off it when I was doing up the Rolls Royce, but I don't know where it is now. So I'm just using some 2.5mm twin and earth, which is actually house wiring, but you shouldn't be connecting it into a plug socket. But again, there's lots of things in this video that I shouldn't be doing. I'm not going to be using any earth sleeving either. Okay, so we are wired up. Obviously, the wires are too big and rock hard to go in there, but it's okay for the purpose of testing. So I am going to, how am I going to do this now? I'm going to plug this into an extension lead so I can plug it in from across the room. Obviously, I'm not putting my hands anywhere near here because I will kill myself. And I've got my torch, flashlight ready in case all the power gets tripped. So it'd be great if we plug it in and basically maybe these will illuminate, or maybe it will allow me to press it. I might use some Guitar Hero or something to press it for safety. I have to cross that road after I plug it in. So how am I doing this? It's going to be upside down. I'm going to get an extension lead on my seat. Right, so I'm plugging it in, but the other side isn't plugged in. Now I'm going to go to safety with my torch, and we'll see what happens. Nothing's going to short there, is it? Let's get rid of all those things there, because it may jump if it goes bang. Right, okay, here we go. This is the moment we've all been building up to. What is going to happen? I'm going to plug it in. It's into a little RCD, one of those safety plugs. Right, plugging it in, turning it on. Are you ready? Here goes. Right, it should be on. Any lights lit up? It hasn't gone bang. Are there any lights lit up? Don't think so. Okay, well it hasn't gone bang, so the bridge rectifier must be okay. Right, I'm going to unplug it. Right, I'm unplugged. Excellent. That's good news. Right, now I'm going to plug in something. Let's plug in a hairdryer, because you'll hear that work, won't you? Imagine if it actually worked. Okay, so let's plug this in. But I've got to get something to tap it, and I don't want to be near it when it goes off. So that's going to be on there. Let's put it on a low setting on that one there. So that's there. I need to find I'm going to get a stick. How easy do they turn on? Let me see what I can use. Okay, I've got some oak edging here. Originally was 2.4 meters, but it's cut down now to about 1.5 meters because I made a frame for the Samsung, the Frame TV. Rather than buying a frame, I made one. It looks much better. Right, that's going to work, and I think I feel okay from here. Right, let's plug it in. I'm in. It's on. Here goes. From a distance. Ready? What's it going to do? I'm nervous. It didn't click. Here it goes. What? It's not working.
Ha ha.
Oh, what an anticlimax. That's not working. Do you have to hold it in for a few seconds? Surely not. Oh, what? What an anticlimax. Let's unplug it. Right, it says here that when you power it up, it should have red LEDs. They'll start to blink and the socket will be ready for setup. And there is no LEDs on there, is there? So that's no good. I shouldn't be wasting any more time on it. because we can see there was extensive damage on the inside and I've already made a good attempt to get it back to normal. I just want to have one more quick look in case there was something that I've missed. I've changed so much on it, just in case there was something that I've missed. So I take it all apart again, and this time I concentrate on the Wi-Fi socket because I go across the components and I find the resistor that should be 10,000 ohms, but it's measuring 1 ohm, which doesn't seem right. So let me show you that bit now. I'm just going to test the resistors. Oh, also I just want to check, well, we know we've got continuity, don't we? Let's just make sure we have got continuity on that last one to here. Yeah. Yeah, the connection's okay. Right, 700 ohms, what should it be? .103, so that should be 10,000. But it's because it's over here, you see. So it's going to measure different. So again, this should be 10,000. Hold on, this is 1 ohm. 1 second, have I read that wrong? Yeah, that's weird. Right, okay, we might have to come back to that one. That's it should be 10,000 and it's measuring, yeah, 1.7 ohms. What? Okay, I'm going to add some heat. I'm going to take that off here. I'm just measuring the resistor. Yeah, there you go, 10,000. So it's the actual, the pads that's doing that. Yeah, the pads are 4 ohms. What's that about? My leads are currently 5 ohms when they're together. So looking at the traces feeding this resistor, one side goes to a switch, the switches are actually working fine, and the other side goes through the board and it looks like it goes into the Wi-Fi chip. So the Wi-Fi chip is covered with a shield. I just want to take the shield off in case something looks dodgy. There might be a shorted capacitor or something like that. And then what I do is I notice that the chip is getting warm when 3.3 volts is put into it. So I'll put IPA on it, and on this next bit now you can clearly see the IPA is burning off nicely on one part of the chip. So unfortunately it means the chip itself has failed, which is very bad news. So it wasn't just the bridge rectifier, it wasn't just the fuse, it wasn't just the transistor, it wasn't just the diode, it's also now the main Wi-Fi chip. Right, check this out now. When I use IPA on it, you can really see that there's a heat spot in the middle. Because on the FLIR cam it's just glowing everywhere, but with the IPA you can physically see when I tap this on and off the heat spot right in the middle. I think the chip on the Wi-Fi board has blown. So if you have a look here, I've just got 3.3 volts, and watch this, flood everything with IPA, yeah? So you can see it now, watch this now. There, you see here? Yeah? And tap. It's just here on the top left. Just here. Yeah, in fact I'll hold it down there. See? Cover it up again. Tap. I don't think that's normal. I'm just going to look up what this chip is. It looks like BL0908. I think when it went on fire, I think it blew this chip, which is understandable. Behold, as if by magic, I give you another module here. I'll tell you later. Anyway, check this out. This is the original faulty one. And do you remember the resistor? The resistor's back in place. Do you remember the resistor on this one was like 1 ohm or something, or 1 point something ohms? If you have a look there. Yeah, 2 ohm. And my leads are currently 1.5 ohm. If I go onto the same resistor here, it should be 10,000, and look at what it is. Yet we know it's not the resistor. There you go, 10,000. Yeah. So clearly, I'm not going to take the cover off this one, but clearly the chip has definitely gone on this one here. Right, so, and that's why it was getting so hot. So let's put this one on. I've just got mixed up on what's what. Oh yeah, that's the old one. Let's put this one on, and now let's see if this will finally come to life, or will it all explode because of the different bridge rectifier, the different fuse, the different transistors, and the different diode. I think it is going to actually work. So what we want to see is when we press these buttons, we want to see these lights illuminate, or maybe because this is a brand new one, maybe it will illuminate from the very beginning, wanting to be connected. Right, so I've got it here. I'm going to get my stick ready so I can press the buttons. Make sure nothing's short in here. Okay, I feel safe. I'm going to plug it in now and zoom out a bit more. Hopefully we'll see some little lights light up. Right, is it going to go bang? Unplug it in, I'm going to turn it on now. No bang. Is there any lights lighting up? Yes, look at that, there you go. Result, it's flashing. Can you see that? Brilliant, right, let's unplug it. And let's put it back together and see if I can download the app and connect up something. Oh, result. Right, I'm going to put it all back together now. Next time you see it, it will be back together, and I will have hopefully downloaded the app ready to connect. Right, I'm going to record this bit purely in case it goes boom as I connect it up. Oh, it's found it. Oh, it's wanting me to update to the newest firmware. Should I do it? Let's give it a go. Just going to stand back. Wow, it looks like it's done. Why is it saying that again? Let's do update again. Let's see if update complete, finish. Okay. You think that would go off it there? See, that's what's annoying. You know, I've got to go out of the app and back into it now because it just seems to have frozen up. It's not great. Well, it is here. It says MMV socket off. So now let me get my hairdryer. I wish I'd put this in a back box now to make it safer. Right, hopefully it's not going to go mental. Well, I should be able to plug that in. So worried. We're in. Right, let's see if we can... So the left one is called MMV and the right hand one is called King, obviously. So should we see? Should we tap it and see if it comes on? 1 second, so we're on there. Let me put it out this way. You'll hear it working anyway. Here we go. It might go bang. I'm going to do it from across the room. Right, I'm doing it now. Oh my God, you know how happy that makes me. Right, let's get something plugged into the right hand side. Unbelievable. Right, let's do a charger. That should light up, shouldn't it? Nice and careful. Carefully does it. We're in. Now, is King going to work? I'm going to do it from across the room again. That's how much confidence I have in my work. Wow, I heard it click. Check that out. No way, that's amazing. Fantastic. That's amazing. Right, last thing I'm going to do is, I quite like the idea of it. I'm going to have to, I'm going to press the button and see if it comes on with the button. Is this where it's going to go bang? I'm going to use my stick. I'm using my stick for this. Wow! Unbelievable. Oh, and it updates here. It updates on here. Let's do this side. Oh, I'm so happy. What a result. Now, can you turn it off on the app? You can. Oh, that's so good. Okay, let me get rid of this now and finish up the video and tell you what I had to buy. Oh, got there eventually. You don't know how happy I am to actually see that work. Again, another video where I seem to put way too much time into it. Now, the fault on this one was a shorted diode, a burnt out fuse, a blown up transistor, these things are all super small, and the bridge rectifier was gone. And the main thing was the actual chip. So nothing else on that board, it was the chip that was gone. So how did I actually get it to work? Well, I don't think you're going to be able to buy one of those chips because when I turned it on, it said updating the firmware. So I presume it has firmware built into the chip from the manufacturer. So even if I did find that little Wi-Fi module from AliExpress, I wouldn't have the software or the firmware or whatever to put onto it. So how did I get hold of one? Quite simply, I went down to Screwfix and I bought one. The one that Simon sent me was a rounded profile one. It cost $16.99 or $17.99, not sure. But the square profile one, because I presume it's slightly less popular, was only $14.99. I bought the square profile one to save myself a couple of pounds. The inside is exactly the same. So you might be thinking, why on earth would you buy something working, take bits out to fix something else? And you'd be completely right. There's absolutely no point in doing it. But what you need to remember is there's absolutely no point in fixing that. Who in their right mind would fix that when you can buy one for $14.99 or the rounded one for $16.99? Nobody would fix it. It's not worth anybody's time. This was done purely for the video. And isn't it much more entertaining, in my opinion, to have it working at the end, no matter what it takes, than have it not working? And to prove what the fault was. Personally, I would never use this. It's got a different bridge rectifier in, it's got different transistors and a different diodes in as well. Now I'm sure those diodes are just going to be something to do with like flyback. You know, when a coil's energized, then when you turn that off, that energy needs to go somewhere, and I think that's what the diode does to stop it damaging other components. And I'm sure the transistors would work just fine, but when you're dealing with mains electricity, in my opinion, it's not worth the risk. So I think if I had one and it failed, personally I probably would take it apart to see. Would I get involved in swapping a load of components over? No, because you're going to end up spending more money than it costs to have a working one. And when you've got a brand new working one, you've also got peace of mind and also a guarantee as well. So yes, it's completely pointless buying a second one to fix a faulty one, but not for the purpose of the video. The same way that often I put things together again at the end of the video before testing them, so I can have an outcome. In real life, of course I would test when everything is all in bits, but this, although this is real life, it's also not real life. I have to make a video that's slightly entertaining. So if I was to show you it working on the bench, then when I say, oh, I'm going to spend the next half an hour now putting it back together, cleaning it, this, that and the other, everybody's gone by then. That's why you find with YouTubers, they often put everything together and show it working at the end because it's a nice end of the video. I know it's not what you do in real life, and people always say to me, it makes me mad that you don't test when things are apart. But that's because this isn't a repair shop, it's an entertainment video. If I was doing it myself, of course I would be testing when things are apart. But for the purpose of the video, it's nice to see it working at the end, and then you can end the video. So yeah, a completely pointless video, but not a pointless video because it's interesting to see what went into it. So a massive thanks to Simon for sending this one over to me. I actually found it interesting seeing the different things that were faulty, but I don't know, was it the bridge rectifier that went faulty that took everything else out, or was it the diode that shorted that then messed everything up? So if you could add that down to the comment section below. And what do I think of these? Well, they're extremely clever, but you're going to set yourself up for a whole world of pain, because normally when you have a normal socket, that socket will still be working in 30 years time because there's just a mechanical way of switching it on and off. There isn't any electrical stuff in there, there's just massive tracks. So there's nothing actually to go wrong. So although these are cheap, you need to think how often they're going to fail. Remember, this is energized all the time when it comes to like the bridge rectifier and stuff. So it's not going to be there. It's unlikely if you fitted 20 of these in your house that in 20 years time, all 20 are still going to be working. Yet if you were to get MK sockets or even cheaper sockets, 20 years later, you know all 20 of them will probably be working. So would I swap over to these? Yes, if I had a hidden socket. If you've got a hidden socket behind a heavy bed or a heavy wardrobe that you want to use, then fantastic. Or if you need something that can be controllable by an app. But I reckon there's loads of people out there that just want to make their home smart and they're fitting all these when they don't really need them. And I think that's wrong, because it's just going to end up in landfill, and it's just going to end up in you having to probably get an electrician out to swap something out when there's no real need for it, especially when you can buy the plug-in ones. I know these are neater, but that's my opinion anyway. I think it's a great idea and it's lovely to see it working like that on the app. And if it was hidden away, I would definitely use one. But would I swap my sockets over to them? No way. I'm trying to simplify my life as much as possible. And what I've realized with home automation is, for me, it's much easier because I'm able-bodied still to get up and turn a light switch on or off, or go to a dimmer and go on or off, rather than having to get my phone out and mess around with things. And even then, when I did the firmware update, it didn't go through properly. The update went through, but can you see it crash? Had to go out and back in again. How much easier is it to get up, and how much healthier is it for you to get up and turn that light switch on and off, turn your music on and off, turn your TV on and off? That's what I think anyway. I was massively into the idea of home automation years ago when I was doing my own house. I don't know what's happened to me recently. I can't be bothered with anything. I just want simplicity. And years ago you had simplicity. And I think as we go more into the future, more and more people will just want simplicity. Anyway, I hope you enjoyed the video. Massive thanks to Simon for sending it over to me. Hopefully next time I'll be able to fix something in its own right without having to buy another socket. But this one here was unfixable because I think you need a special program chip Wi-Fi card from the company themselves. But again, if I'm incorrect, please add that down to the comment section down below. Until the next time, see you then. Take care.
I went out and tried to cut a pine tree down, fell through the ground like Alice. Oh, what a sound! This must be a nest. I got rocks and sticks against my chest. I'm Alice. Dear Queen of Hearts, I'ma grow you white roses so you can learn to be kind. Tell King of Hearts to arm all his forces so you can learn to be